Good afternoon, class. We are looking at pre-calculus practice test number 3. Module 3 covering chapters 5 and 6 and 7, chapter 5 trigonometric functions, chapter 6 periodic functions, and chapter 7 trigonometric equations and identities. We want to answer the following question, starting with the conversion of 315 degrees to radians. And so I'm going to remind everybody how we do that. The easiest way is to recognize pi is 180 degrees. So the ratio of d to 180 degrees is the ratio of radians to pi. So any one of them is missing, you can find. For example, here, d is 315. So you replace the d with 315 and you find the missing r. Therefore, the missing r would be this d times pi over 180. Which gives us 7 pi over 4. So this would be a nice formula to remember. We're going to convert 9 pi over 5 from radians to degrees, so it's the reciprocal of that. Or you can say, I'm going to put 9 pi over 5 here and find d by the cross product. Either way is fine. So multiplied by 180 over pi, of course, the pi's cancel each other. And then so 9 times 180 divided by 5, or 9 times 36 is 324 degrees. Convert 3 radians to degrees. We do the same thing. Again, in this formula, radians. So you replace this one with 3, so you multiply by the same 180 over pi. And that gives you 540 over pi, and we go with a couple of decimals, 171 degrees, 170.89 degrees, about 172 degrees almost. You want to find the exact value of 14, a sine of 14 pi over 3. I'm going to remind you that in the case of a sine and cosine, 2k pi, k is an integer. Sometimes they use 2n pi is the period, and you get the same function back. In the case of a tangent and cotangent, is just k pi. And so with that being the case, all you have to do, take out multiples of 2 pi. Okay, for example, you may notice that this is 12 pi over 3 plus 2 pi over 3. Why 12 pi over 3? Because this is equal to 4 pi, or 2 times 2 pi. 2 pi is a complete revolution. And so we end up with sine of 2 pi over 3, which is square root of 3 over 2. The reason why 2 pi over 3 or 120 degrees, sine is positive in the second quadrant. And as you can see, again, another thing I want to remind you, and you have this one, the reference arc, theta sub r, is pi over 3. So it's the same as sine of pi over 3, and you have to account for the sine. The sine for this sine function is positive in the second quadrant, so just the same as pi over 3. Again, there's a lot of information involved here, basic trigonometric functions. I'm going to answer the following. Name the quadrant that contains the terminal point of this arc, t equals 2. Well, let's again refresh everyone's memory. This is a unit circle. first quadrant, second quadrant, third quadrant, fourth quadrant, 0 to pi over 2. Pi over 2 is the same as 90 degrees. That's the first quadrant. Then from pi over 2 to pi, pi is 180 degrees. That's the second quadrant. The third quadrant, 3 pi over 2, pi to 3 pi over 2, where 3 pi over 2 is 270 degrees. And from here, 270 degrees to 2 pi or 360 degrees, that becomes the fourth quadrant, just to refresh everyone's memory. And as you know, the unit circle, x squared plus y squared equals 1. Okay. So again, reminding you of some of the important formulas, class. Sine t is the y coordinate, cosine t is the x coordinate, tangent is the ratio of y over x. So if you happen to have a theta here, any angle, and then you call this t, then y, x, tan t. So if you have any point, oh, we have it right here, x comma y, then x is the same as cosine t, y is the same as sine t. X cosine t, y is sine t. And since tangent is the ratio of sine, tangent is sine over cosine, we have y over x. So let's write all of those formulas. Tangent is y over x or sine over cosine. Cotangent is x over y or cosine over sine. Cosecant is 1 over y or 1 over sine theta. Secant is 1 over x or 1 over cosine theta. As long as we have sine and cosine, pretty much we can figure out the rest of it. Okay. Now, since pi is about 3.14 roughly, pi over 2 is half of that. So this number is almost 1.57. Pi is 3.14, as I mentioned. Okay. And then we have the 3 pi over 2. 2 pi is 6.28. And so when we look at this one being 1.57, this one being 3.14, number 2 is in between. So that makes it the second quadrant. But just let's go over everything. Over here, the first quadrant, the t should be between 0 and roughly 1.57. Precisely pi over 2, but roughly 1.57. In the second quadrant, between 1.57 and 3.14. In the third quadrant, between 3.14 and 4.71, roughly 3 pi over 2 is 4.71. In the fourth quadrant, between this number 4.71 and 6.28. And again, since 2 is right here, that would be the second quadrant as far as the answer to number 2 is concerned. So now, again, a lot of information here. I want to go over the synopsis of that. Quadrant. Find the exact value of cosecant of 11 pi over 2. And we should recognize that the reference arc is pi over 2 and cosecant is 1 over sine. Okay, so 11 pi over 2. Remember, we want to take out multiples of 2 pi. So I can take out 2 pi or 4 pi over 2 or 4 pi, which is equal to 8 pi over 2. Therefore, if I said 11 pi over 2 minus 4 pi, that gives me 3 pi over 2. That's how we get 3 pi over 2 here. As you know, sine of 3 pi over 2 is -1. 1 over -1 makes it -1. That's how you arrive at the answer, again, without a calculator, knowing all the common arcs, okay? That makes it extremely important, everybody. Determine the length of arc of a circle and area of a sector formed by the central angle. Theta is 1/2 radians, and r is 10 meters. So first, I want to remind everyone that when we have a case like this, S is called the arc length, and that is equal to r theta. This is the sector, and the area of a sector is 1/2 r squared theta. So those are two pieces of information. And basically, it comes from the fact that circumference of a circle is 2 pi r. So that gives you, and the whole revolution is 2 pi, that gives rise to S equals r theta. And area of a circle is pi r squared, or 1/2 2 pi r squared, and it gives rise to the formula for the area of a sector. So we want to find S equals r theta here. And by the way, it's important to know that theta must be in radians. And so when we put it in, 10 times 1/2 equals 5 meters. Okay. And of course, as far as the units are concerned, this is where the units come from. The area is 1/2 r squared theta. So 1/2 10 squared times theta. This is 100 divided by 4, or 25 square meters. The units are varied. Okay. Now, in part B, we are looking at the same concept. The only difference between part B and A is that this is in degrees. As you know, 60 degrees is pi over 3. It's one of those common arcs. And now we are going to use S equals r theta. So 5 times pi over 3. And that's 5 pi over 3 precisely. This is an exact answer. And it's a rough estimate. And the units, always when you are given units, you want to give back proper units. This is exact. And you go with pi equals 3.14, it's not a good idea. Make sure you give it enough decimals, however many decimals they ask you. For part of A equals 1/2 r, 1/2 r squared theta, we just plug in, which makes it 25 pi over 6. Again, that's an exact answer, rough estimate, and we end up with 13.090 square feet. Each wheel of a car with a radius of 15 inches makes 3 revolutions per second. How fast is the car moving in mph, miles per hour, which is known as a linear velocity? So let's discuss a couple of things here. First of all, again, this is the concept of a angular velocity versus a linear velocity. So the formula is the linear velocity is total distance over time, or S over T. So the distance we cover over time, whereas angular velocity is the angle that we cover over time. So linear velocity S over T, and angular velocity theta over t. Okay. Another way is 2 pi times RPM. RPM stands for revolutions per minute. Sometimes we may have RPS, revolutions per second. Revolution, a complete revolution is what? 2 pi radians. So for example, if we say 10 revolutions, that means 10 times 2 pi. That's why we have 2 pi times RPM. This is another way of writing it. Now, since V is S over T, and we know S to be R theta, we can replace the S with R theta, and it becomes R times theta over T. As you know, theta over T is omega. V is R omega. V is R omega. So we, in essence, prove the formulas. And so what is given as we read this question? R is 15 inches. It's important to write the given. It makes 3 revolutions. So omega is 2 pi times RPM. So there are 3 RPS. In this case, I'm going to say RPS. And we are interested in a linear velocity, or simply V. So first, omega is 3 times RPS means 2 pi. So 6 pi, 3 times 2 pi means 6 pi. That would be radians per second. This is the angular velocity. This is the angular velocity. V is R omega. So we basically multiply this by R. So 15 inches, radians per second, gives you 15 times 6, 90 pi inches per second. Basically, radians, they don't have units, just radians per second, so inches per second. Now, and we are done, except we want to write this in miles per hour. So I'm going to remind you that we want to go from inches per second to miles per hour. And remember, for example, 1 mile is 5,280 feet. 1 foot is 12 inches. 1 hour is 3,600 seconds, or you can say 1 hour is 60 minutes. 1 hour is 1 minute is 60 seconds, and change them accordingly. So when you want to multiply, it's important to know. I'm going to write one thing first. If you said 1 foot over 12 inches, this is a unit conversion, or 12 inches over 1 foot. They're the same. But which one do we have to use? We have to use it properly so that we get here. That's why this is a unit conversion. This is also a unit conversion, meaning 1 foot equals to 12 inches. Okay. But remember, we want to get rid of the inches. So we put this one at the bottom because the inches will cancel each other. Okay. And the same thing, you want to get rid of the foot. 1 mile is 5,280 feet. You can put this one at top or 1 mile. But we do put this one at the bottom because one to cancel those. 1 minute is 60 seconds. 1 hour is 60 minutes. As you can see, everything cancels out as far as the units are concerned. And when you look at the units, everything is gone at the top except miles. Everything is gone at the bottom except hours. So the units end up being miles per hour. Okay. So that's important to pay attention to. This is how you do the unit conversion, everybody. Okay. Now, all you have to do now, do the math. So you have 90 times pi. Again, don't use 3.14, rather put it in a calculator. Okay. Times 60, and then divided by 12 times 5,280. Use a calculator and come up with the answer. And again, with a bunch of decimals, and then you answer it with however many decimals they ask you. So I was interested in making sure that the units make perfect sense. If the length of an arc is 50 inches in a circle with a radius of 6 inches, we want to find the angle this arc subtends. So first and foremost, what is given? S is 50 inches, R is 6 inches, and theta is missing. Of course, I put all those formula to remind you, we've gone over all of those, and whatever you need, you use it, okay? So this is the arc length. We are going to use S equals R theta and find theta, which makes it S over R, or 50 over 6, or 25 thirds radians. Precisely, you can leave it like that. Of course, it's like 8 and 1/3. We want the area. Area of a sector is 1/2 R squared theta. And replace the R and replace the theta. So you may recognize that these two and these two cancels out one of the sixes. So 6 times 25 or 150 inches squared. So I don't dwell on that. I'm going to assume nobody has any problem with basic math. Find the linear velocity of a cylinder with a 2-foot radius that is spinning at 40 miles per hour. Again, we have all those formulas. Let's see what is given. The radius, 2 feet, 40 RPM, that's omega. V is missing. So that's given. What is given? What is missing? So first and foremost, omega means 40 times. Remember, the moment you see R, revolution, a complete revolution means 2 pi. And of course, proper units. In this case, 2 pi times 40. And when you do the math, it gives you 80 pi radians per minute. That one per minute. Okay. V equals R omega. So V equals R times omega. So 2 times 80 pi, which makes it precisely 160 pi. And this is an approximation, feet per minute. And again, you want to pay attention to the proper units, feet per minute. Find the exact value each of the remaining trigonometric functions of theta, knowing that tan theta is given as minus square root of 3 over 3, and sine is positive, okay? So take a look at what's happening here. There are a couple of things I want to remind you again. As far as the unit circle is concerned, x squared and y squared is 1. But if it's not a unit circle, any radius x squared plus y squared equals r squared, okay? Then x squared plus y squared equals r squared. Any point has coordinates x comma y. Sometimes they call it a and b. Either way is fine. And by definition, if you remember, sine was y, cosine was x for the unit circle because the radius was 1. Think about radius being 1. If the radius is 1, it becomes y, it becomes x. But when it's not, a general shape becomes y over r, x over r. The rest of them just follow the fact that we know the relationship among those. And for example, tangent is sine over cosine. So when you do that, it's y over x. Cotangent is the reciprocal of that. Cosecant is 1 over sine. Secant is 1 over cosine. So as long as you have the first and the second one, you're done. And again, in some context, instead of x and y, they may use a and b. That's why I put both formulas. Either x is a, y is b, or just x and y. It's the same thing. So we know that tangent is negative and sine is positive, okay? Remember, in the first quadrant, everything is positive. Let me just write a couple of things again. So S and C, that means sine and cosine. They are both, and as a result, the same thing for tangent and cotangent, secant, cosecant, everything. So as long as we know those two, we know the rest of it. In the second quadrant, S is positive and cosine is negative. In the third quadrant, both of them are negative. And in the fourth quadrant, sine is negative, cosine is positive. Okay. So what happens is that because in these two quadrants, sine and cosine have the same sign in these two quadrants, that means the first and third tangent and cotangent are positive. And these two must be negative because sine and cosine have opposite sides. Okay. And so this results in the following. We are dealing with quadrant 2 because tangent is negative, sine is positive, and theta becomes 5 pi over 6. I hope you know how we arrive at it. There are a couple of different ways. One easy way to remember common arcs, and that is the following. In order, remember when tan theta is square root of 3 over 3, this is how you go with the reference arc. Reference arc. Tan theta is square root of 3 over 3. You should know that theta is pi over 6. By the way, when we say reference arc, by definition, it's the arc in the first quadrant the closest to the x-axis, okay? So the angle that the terminal sides makes with the x-axis, in this case, this distance, if it's here in this, the closest distance, that is called the reference arc. So theta is pi over 6, as you know, tangent of pi over 6 is square root of 3 over 3. And because it's in the second quadrant, all you have to do in order to get to the second quadrant, subtract this from pi over 6 again. Because this is minus, you have to subtract pi over 6 from pi, and that gives you the precise answer. Again, we talk about common arcs, okay? There's a lot of information here. I hope everybody's comfortable with that. All right, so there are different ways of handling this. At this point, we want to find each of them. So if you want to compare this to this formula, y over x or b over a, you can see that it's square root of 3 over negative 3. The reason why, because you can put the negative at top, the bottom, or in front of a fraction point. However, because we are discussing quadrants, we want to put it either at top or at the bottom, not in front of a fraction point. The reason we want to do that, we want to see whether x is positive or y is positive, or x is negative, y is, maybe both of them are negative, maybe both of them are positive. So with this, the case, since this is a negative value, one of them must be negative. In the second quadrant, it is the x that is negative. So it's extremely important to know where you put the sign. Again, negative square root of 3 over 3. Over here, it's given as such, but I'm changing it, put it at the bottom because I want everybody to see x is negative 3, y is positive 3, and plug it into all of these formulas. You come up with the answer. The only thing that you need to calculate is r, and r is x squared plus y squared. Take a root. So let's raise to this power, to the power of 2. Okay, so when you do that, this becomes 9. This becomes 3. So r squared is 12. R squared is 12. And r is square root of 12, or 2 square root of 3, because four times 3 is 12. 4 gives us 2 square root of 3. We have those values. And so sine becomes square root of 3 over 2 square root of 3 or 1/2 y over r. Okay, everybody, y over r. I hope everybody is fine with that. Becomes 1/2 and here's the rest of them. Now, in my opinion, when you have sine and cosine, everything else will fall into place. And of course, cosine is x over r, right? X over r. And minus square root of 3 over 2. Remember, you can, if I want to write this, you can rationalize it. Everybody knows how to do that. We go with this formula, x over r minus 3 over 2 square root of 3. And if you multiply the top and the bottom by square root of 3, you end up with this answer. Now, you have the sine, you have the cosine, and you have the tangent. The rest of them are the reciprocals. Okay, cotangent is the reciprocal of tangent, cosecant is 1 over sine, and secant is 1 over cosine. So the rest of them become reciprocals, become extremely simple. Find the exact value of each of the remaining trigonometric functions where secant theta is 2 and sine is negative. All right, remember, secant is the same as 1 over cosine, and right away we realize cosine is 1/2. That means cosine is positive, okay? And sine is negative. And that gives us the fourth quadrant. That's the first thing we need to recognize. Secant and cosine have the same sign. So secant is positive 2, cosine is positive 1/2, cosine is positive, sine is negative, quadrant 4, cosine is 1/2 again. You can write this as cosine theta is positive, and these two result in this, okay? All right, you got the cosine. You want to find the rest of them. And again, you can go with the method of the previous page, okay? The concept of x and y and r. You can also go with the identities, okay? For example, we know sine squared plus cosine squared is 1. And by the way, when you know sine squared plus cosine squared is 1, there are a couple of things that, quickly I'm going to write, you should know. Obviously, it means, for example, that cosine squared is 1 minus sine squared. Or cosine is plus minus the square root of 1 minus sine squared. So they must be clear. Okay, I don't want to go over that again. You've seen them, but I'm going to erase the mess since I need the page. So sine squared plus cosine is 1/2. When you square it becomes 1/4, and sine squared becomes 3 over 4. And there are two answers, plus minus square root of 3 over 4. We have to make a decision what's happening because we are in the fourth quadrant, or they even told us sine is negative. You choose the negative one because of the quadrant. Okay. The rest is immediately cosecant is the reciprocal of this. So negative 2 over square root of 3. And if you want to rationalize it, you multiply by square root of 3 over square root of 3. That gives you the answer, and you're done. Tangent is the ratio of sine to cosine. The denominator is 2 drops, so minus square root of 3. Cotangent is the reciprocal of that, 1 over negative square root of 3. And I guess most everybody knows that is just simply minus square root of 3 over 3. And so we have everything as far as writing them up here. We put everything here, sine, cosine, tangent, and these three are the reciprocal of those three. So I would find those three, and then the rest of them go with the reciprocal. It goes very fast. Simplify using identities. So in this case, we want to replace the secant with 1 over cosine. And now we're going to write cosine is square root of 2 over 2, and cotangent is the same as tangent is 1. So 1 over square root of 2 over 2, that will give you the reciprocal of this, which is 2 over square root of 2, which is square root of 2. Very simple class. We want to simplify this. We take a common denominator of sine theta times cosine theta. So we multiply this by cosine theta, minus we multiply this by sine theta. When I take a common denominator of sine theta, cosine theta. So sine theta times cosine theta plus cosine squared minus sine theta, cosine theta, minus and minus plus sine squared. I'm assuming taking a common denominator is not a big deal for anybody, and we can handle it, okay? All right, we know Pythagorean identity. Sine squared plus cosine squared is 1. Also, 1 plus tan squared is secant squared. 1 plus cotangent squared is cosecant squared theta. Now, and you may remember, if in this case you divide both sides by sine squared, you get this one. If you divide by cosine squared, you get this one. And so if that is the case, then these two cancel each other. You get cosine squared and sine squared, which is 1. 1 over sine theta, cosine theta. And that's 1 over sine theta. We can separate them into 1 over sine theta times 1 over cosine theta, which is cosecant theta times secant theta. One over sine theta times 1 over cosine theta, which is cosecant theta times secant theta. Cosecant theta times secant theta. We want to simplify, and we may recognize this, or we just move this cosine squared, and these two will be 1 plus cotangent squared. These two, they add up to 1 plus cotangent squared, and 1 plus cotangent squared is cosecant squared theta, and we are done. Well, this is cosine, this is secant, and notice this number is 12 pi over 6 plus pi over 6, and 12 pi over 6 is a 2 pi. You can get rid of it. Secant of pi over 6 is 1 over cosine of pi over 6. You can write it in this fashion, and it becomes 1. Or you can write this one underneath this one as a fractional format. All right, we want to simplify this. Cotangent theta plus cotangent of theta minus pi plus cotangent of theta minus 2 pi. And I'm going to remind you, as far as a periodic function is concerned, 2 pi is the period for every trigonometric functions except tangent and cotangent. So this, whether we write minus or plus makes no difference, okay? In pi, that's the concept, okay? And so this becomes cotangent, this becomes cotangent, and therefore we have 3 of those. We are supposed to graph this function by finding amplitude, period, intercept, so on and so forth. And so I want to give you the synopsis of what we need to do. So I'm going to remind you that here's one complete cycle of a sine function going from 0 to 2 pi. The key points, we can make up 4 arcs. So this is 1. This is 2. This is 3. This is 4. In the case of any sinusoidal function, so the period is 2 pi, so you cut the 2 pi into 4 pieces, okay? 4 arcs, 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, 3 pi over 2 pi. This is the best way to, and easiest way to graph this. And the domain is all real numbers because it continues indefinitely on both sides. This is a complete cycle. T is 2 pi, and amplitude is 1 for a basic sine function. A general format as the formula a times sine of bx minus c, in which case you must take the b out. And when you do that, a is the amplitude, okay, and t is 2 pi, let me just write it here and I'll explain it. Period is 2 pi divided by b. Amplitude is the same thing, absolute value of a. The PS short for the phase shift, horizontal displacement is this, C over B. So pay attention when it's negative, it means that if C is less than 0, phase shift is to the left. If it's positive, it's to the right. Also, we have something, some text, they use the terminology, the midline of a function is the horizontal line midway between the max and mean of a function. For y equals sine theta, the midline is the line y equals 0. The horizontal axis. For this one, this would be the case. So let's graph it. Let's see how we are going to graph this. And there are different approaches, and this is the general shape that was discussed. First and foremost, the amplitude is the absolute value of this. The period is 2 pi divided by b. In some text, they call it 2 pi over omega. I wanted to show you both formulas. If we go, some text, they call this omega class, okay? And so if you want to go with that, 2 pi over omega, if it's b, 2 pi divided by b. And in this case, b is pi over 3. 2 pi divided by pi over 3. I hope you realize pi cancels out. The pi 3 comes up and it becomes 6. Phase shift, there is no phase shift here, okay? There is no phase shift. So there are 4 parts, if you remember, 4 arcs. So we're going to cut the period into 4 equal parts. 6 divided by 4, 3/2 or 1.5. So since there is no phase shift, we start from 0 and we go to 6 and cut it in 4 parts. The first one would be 0 to 3/2. The next one would be 3/2, 2, and then add 3/2 to this, which makes it 3. And you keep on going. So then from 3, add 3/2. Remember, 3 6/2 makes it 9/2, 9/2 to 6. So put the 0 here, put the 6 here, and just keep on adding this number. So the beginning, the end, so on and so forth. Okay. Now, one way to do the math is to take care of this and then move it up by 4 units. So to take care of this, basically you plug in 0 and so on and so forth. As an example, if I plug in 0, and by the way, 3/2 or 1.5 is the same. If I plug in 0, I get sine of 0, which is 0. If I plug in 1.5, 1.5 divided by 3 is half. Pi over 2, you know pi over 2, the sign is positive 1. This makes it negative 6. And you can continue with the rest of them. 3 gives you 0, 4.5660. So those are the points for this. We are completely ignoring that for now. We are ignoring the plus 4. And so we plot those pairs, 0, 0, 1.5, negative 6, 3, 0, 4.5, 6, 6, 0. And that's one complete cycle. Now, what do we do? This would be the graph if we didn't have this part. So that was a complete cycle, and this goes indefinitely. Now we're going to shift this up because the vertical shift is a 4. All you have to do, write the same numbers here, and these numbers, add 4. So this becomes 4. This becomes negative 2, 4, 10. This becomes 4. So we are adding 4. We can go also on the left side, the same thing. And so basically you move this line up by 4. The midline is y equals 4. And that's the graph. So this one basically shifted up by how many units? 4 units, that's all. Again, this is one way to do that. I'm going to quickly show you a second method. If you don't want to go with this one and you want to pretty much directly go to this one, you can. We've done all of this. Okay, so that means we have this, we have the amplitude, we have the t, we have d equals 4. And so what we have, also we have those. So you don't have to plot those. Everything else is there. Okay, so now we are going to go with the second method. So we have everything from the previous page. And as I mentioned, those are the points you have. So you treat this as though this is your, in essence, x-axis. Notice what happens. Those points have moved up by 4. And the other 2 points. So this is your complete cycle, just one. And this is all of it. Now, I don't know which one is easier. I wanted you to be, familiar with both methods, and you choose the method that works the best for you. I spend enough time on that so we can have an easy time with the rest of it. All right, we want to do the same thing for this function. And what we are going to do first and foremost, we're going to take the 3 out. This is y equals 2 cosine of 3x plus pi over 2. So we're going to take the 3 out. The amplitude is the absolute value of 2. The period is 2 pi divided by 3. Now there is a phase shift. There is a phase shift of minus pi over 6. That means it has shifted to the left by this much, by pi over 6 to the left. So since the complete period is 2 pi over 3, we are going to go from minus pi over 6 to minus pi over 6 plus 2 pi over 3. A complete, and we're going to divide this by 4, and I'll show you what we do. But first and foremost, minus pi over 6 with 2 pi over 3. This is the bracket that is a complete cycle. So when we add 2 pi over 3, which is 4 pi over 6, with this one gives us 3 pi over 6. which is pi over 2. So what does it mean? It means we're going to start from here and we're going to end here. And we cut the period into 4 pieces, pi over 6. So this is the beginning. Now, from here, we add pi over 6, we get 0. The next one, 0 to pi over 6, and so on and so forth. So again, start with the beginning, minus pi over 6 here. Add pi over 6, we get 0. Then 0 here, add pi over 6. Then pi over 6, add pi over 6, and so on and so forth. So those are the ones that you have. And here's the x coordinates, minus pi over 6. You plug in 3 times minus pi over 6 is minus 3 pi over 6, or minus pi over 2 with pi over 2 becomes 0. Cosine of 0 is 1 times 2 is 2. You can figure out the rest of it. 0 makes it pi over 2. Cosine of pi over 2 is 0. Okay, so on and so forth. It's very easy to figure those out, everybody. And so that's the graph. So pay attention to the way we do that. We are going to go from minus pi over 6 to pi over 2. At minus pi over 6, it's 2. At pi over 6 is negative 2. At pi over 2 is positive 2. And then in between, it's 0 here, it's 0 here. This is a complete cycle. We're going to go indefinitely on each side. And that depends whether they're asking you for a complete, so for a complete period class, we would be done here, but we are adding in case. So you want to pay attention to the way they. What about this function, tangent? Okay, so by the way, when it comes to the rest of them, they don't have an amplitude and things like that. Okay, so first and foremost, t is pi over 1/2, which makes it 2 pi. And if you recall, we have a couple of asymptotes, vertical asymptotes, and the graph looks almost like y equals x cubed. And the asymptotes normally is x equals minus pi over 2 and x equals pi over 2. But because it's 2 pi now, okay, then the vertical asymptotes are at negative pi and pi. So domain x can't be n times pi. If you recall, it couldn't be odd multiples of pi over 2, okay? And the range has no restriction. It's all real numbers. Vertical asymptotes x at n pi. For example, in this case, minus pi and pi for one complete cycle. If you plug in a 0 here, you get 0. If you plug in pi over 2, you get pi over 4. Tan of pi over 4 is 1. If you plug in minus pi over 2, you get minus pi over 4, which is negative 1. So having a few points. So those are the vertical asymptotes. Okay. Those are a few points. And that's the graph. Again, I want you to pay attention that normally this is minus pi over 2 and pi over 2. However, this is for a basic tangent, tan of x, but it's 1/2 x, so it has changed the period, which is normally pi, to 2 pi, so it has changed everything, okay? So the vertical asymptotes becomes n pi, whereas the regular basis is 2n plus 1 times pi over 2. For this function, let's y equals 3 cosine of pi x minus 4. Amplitude is absolute value of 3, which is 3. T is 2 pi divided by pi, which makes it 2. There is no phase shift, but if you graph this, it just shoots down by 4 units, just for the sake of argument. There is no phase shift. And so if we want to cut this into 4 equal parts, We're going to divide 2 by 4, which gives us 1/2. And so because there's no phase shift, we start from 0, 0 to 1/2, and then 1/2 to 1, and the rest of them 1 to 3/2, 3/2 to 2. And so we plug in 0. If we plug in a 0 here, as you know, cosine of 0 is 1. So we get 3. Minus 4 gives you -1. If we plug in 1/2, cosine of minus pi over 2 or pi over 2 is the same 0. So the answer is -4. And the vertical shift, of course, is 4 units, as I mentioned, and therefore you have those. Again, I showed you how to calculate the 0, 1/2. You can do 1. Cosine of pi, by the way, is -1 times 3 is -3, and -4 becomes -7. So all you have to do, plot, this is y equals -4. It's been shifted. So this one is shifted down by 4 units. So if you plot those 3 pairs, this is 0, -1. This is the 0. Okay, look at this arrow. This is the 0. One and -7, 2 and -1, and these two in between give us the shape of cosine that has been shifted down by 4 units. What about y equals cosecant pi x? In general, I want to remind you that cosecant is 1 over sine, and you basically graph the sine and flip it over. That's the general idea. And so we are going to go with y equals sine pi. So we're going to graph this and then flip it over. So the amplitude is 1. The period is 2 pi divided by pi, which makes it 2. I don't see any phase shift. We're going to cut this into 4 equal parts. So we're going to divide number 2 by 4, and we get 1/2. And it basically works like the previous page. 0 to 1/2, 1/2 to 1, 1 to 3/2, 3/2 to 2. And now you're going to plug in, for example, if I plug in 0, I get sine of 0, which is 0. If I plug in 1/2, is pi over 2, which makes it 1. If I plug in 1, sine of pi is 0, so on and so forth. So plug in 0, 1/2, 1, 3/2, and 2, and there is no vertical shift. So those are the 3 points here. These are the max and mean, and that's the graph of sine. Now, as far as the cosecant is concerned, we're going to flip over the graph, and it looks like that, which gives rise to the domain. X can't be n. For example, anywhere that you see 0, it's the reciprocal of that, right? So it can't be. Range, everything from -∞ to -1 union 1 to infinity. So basically from -1 to 1 is not covered. And because the domain X can't be n, those are vertical asymptotes. For example, X equals 0, X equals 1, X equals 2. And of course, it goes indefinitely on both sides. But this is a complete cycle, complete period. That's why, okay? If you look at this function, y equals sine pi x plus 2 minus 5, the amplitude is what you see here, the absolute value of 1 over 1. Notice we took the pi out here, okay, because it's pi x plus, you take the pi times x plus 2 over pi. So t is 2 pi divided by pi over 2. Phase shift is negative 2 over pi. Divide this by 4. So we're going to go from negative 2 over pi to negative 2 over pi plus 2. And roughly those are the numbers. Again, because the numbers are messy, I wanted to just show you it's really not that big of a deal. That's the process. We are going to cut this into 4 parts. We need to go with 1/2. So from negative 0.64, we add 0.5. Class, we can add 0.5 or 1/2. Let me just write this 0.5. Okay. And so if I add this to this number, gives me negative 0.14. And we continue. And so we get the proper answers. So when we add 0.5 here, we get positive 0.36. When we add 0.5, we get positive 0.86. And 0.86, we add 0.5, we get 1.36. Okay. Now we plug in those values into the original function of this one. We evaluate them if need be using a calculator, and then don't forget there is a vertical shift, 5 units negative down, 5 units down. And so we are going, and again, this was for this part. Now we're going to go down, so we're going to subtract 5 from each part. This was this one, okay? So we go down. And that's the graph. The graph of sine function that has been shifted minus 2 over pi, that means to the left, the blue one. And now it's coming down by 5 units, coming down by 5 units. Okay, so I hope you see we have the original sine, they shifted to the left and coming down by 5 units.